In Mod 3, the first thing that we are going to do is talk about reference angles. And we need to define what a reference angle is. For every non-quadrantal angle, now remember a quadrantal angle is one that lands on an axis. So you're talking 90 degrees, 180 degrees, 270 degrees, 0 degrees. There is an acute angle called the reference angle. A reference angle, which is noted as theta prime, is the positive. It's really important to remember that a reference angle must be positive, acute angle formed by the terminal side of the angle and the x-axis. Again, that's also very important. Reference angles are always in relation to the x-axis. What I have given in this figure shows where the reference angle is in relationship to the original angle in each quadrant. If you are in quadrant 1 and your terminal side is in quadrant 1, then your original angle goes from the x to the terminal side, and so does your reference angle. In quadrant 1, your given angle and your reference angle are the same measure. That's the only time where that happens. If you are in quadrant 2, your original angle starts at 0 and terminates in quadrant 2. So there is your terminal side. So theta goes from 0 to the terminal side. Remember that theta prime must be from the x-axis to your terminal side in that same quadrant. So theta prime is right here. So there's theta prime. If your original angle terminates in quadrant 3, so here's our terminal side, your reference angle goes from that terminal side to the x-axis in that quadrant. So we're going to go up from the terminal side to the x-axis. There is theta prime. And if your original angle ends in the 4th quadrant, there's your theta, and here's your terminal side. Your reference angle is always from the terminal side to the x-axis within that quadrant. So our terminal side to the x-axis in 4th quadrant is here. So this is theta prime. In our first example, we are asked to find the reference angle for the given angle theta. And our first problem is theta of 75 degrees. So let's think about where 75 degrees is. This is just a sketch, so don't worry about being exactly perfect. But 75 degrees is less than 90, so it's going to end in the 1st quadrant. So there's my theta of 75 degrees. In the 1st quadrant, this is the only place where this happens. Your given angle and your reference angle are the same thing, because to get from your terminal side to the x-axis is exactly the same as what you had originally. So our theta prime is 75 degrees. On example B, we are given a theta of negative pi over 8, so we are in radians this time, and we are to find theta prime. So remember what happens when you are doing a negative angle. You start at 0 and go down. So we start here and go down. We don't go down very far. We're only going down negative pi over 8. So there's our theta. When you are in the 4th quadrant, your reference angle is from where you ended to the x-axis in that quadrant. So we're going to go from where we ended up to the x-axis. So that's our theta prime. Well, we already know that in the negative, that distance was pi over 8 radians. In order to do a reference angle for a negative angle in the fourth quadrant, it's the same measure, but the positive version of it. So what was that angle measure? Pi over 8 radians. On example C, our given theta is 210 degrees. So let's think about what we're doing here. To get to 210, we're going to start at 0. Here's 90. Here's 180. We're going to go a little bit past that 180 down into quadrant 3. So here's theta. Our theta prime is from where we stopped up to the x-axis in that quadrant. There's theta prime. What we have to think about is how big is that? Well, if you go from 0 to 180, how much farther do you have to go to get down here? You go 30 past that. So theta prime is 30 degrees. On D, our theta is negative 120. So let's sketch that and see what's going on. To do negative 120, we're going to start at 0. We're going to go down, here's 90, and we're going to go past that a little bit into quadrant 3. So here's theta. If we are in quadrant 3, our reference angle goes from where we stopped up to the x-axis. There's theta prime. So let's think about what we did to get theta. We went 90 degrees here, and to total 120, we had to go 30 more degrees over here. So when we get into the third quadrant, we used 30 degrees of it. So what does that leave in this space to be a total of 90? It leaves 60 degrees. So our theta prime is 60 degrees. On example E, we are back into radians, and we have a theta of 10 pi over 9. What might be helpful for you is to think about what 10 over 9 equals in a mixed number. 10 over 9 could be written as 1 and 1/9 pi. So that might help you if you need to use that idea. So if I need to go 1 and 1/9 pi, that means 1 pi takes me all the way over here. 180 and 1 pi are the same thing. I need to go 1/9 of a pi past that, so I need to go down here. My terminal side is in quadrant 3. There's theta. So my theta prime is from the terminal side to the x-axis. Well, think about what we said we did. We said that this much was 9 over 9 pi, which is 1 pi. How much extra did we go to get down here? We went 1/9. So we could say that theta prime is 1/9 pi, or you can say pi over 9. They are the same thing. On our last example for finding reference angles, we are told that theta is negative 28 pi over 15, and we are asked to find theta prime. So let's do the same thing that we just did on E. Let's change this to a mixed number. How many times does 15 go into 28? It goes in once. First, it's negative, don't forget that. It goes in one time, and then how many would be left over? 13/15. So 1 and 13/15 pi is the same thing as 28 over 15 times pi. So what's that mean for finding our reference angle? We're going in the negative direction, so we're going to start at 0 and go down 1 full pi. And then we're going to go 13 out of the 15 to make another pi. So we have to go all the way over here back into quadrant 1. So here is our theta. Theta prime is from where we ended to the x-axis in that quadrant. So theta prime is here on this example. So let's think about what we did. We went, here's 1 pi, right here is 1 pi, and then this much is 13 out of 15. If you are trying to make 1, you would need 15 out of 15. So how much is left over here? 2/15 is left over here. So what we now know is that our theta prime is 2/15 times pi, or 2 pi over 15. I'm going to use this figure to help you understand why the definition of the trig functions within a circle is what it is. So let's think about if we had an angle that ended in the first quadrant. So here's my theta. If I think about where that theta met that circle, if I go right here, and then I drop a perpendicular so that I have a 90-degree angle, then I would have a right triangle. And in relationship to that theta, we could say that this is the opposite. Here's the hypotenuse, and here is the adjacent. So think about what we said about sine. We said that the sine of theta equals opposite over hypotenuse. If we are looking at this triangle that is within this circle, the opposite side is the same thing as the y amount on the vertical axis. So the opposite equals y. The hypotenuse in this triangle goes from the center to the circle. Anything from the center to the circle is a radius. And the adjacent is the x value on that axis. So using x, y, and r instead of opposite and hypotenuse, we would get y over r. Think about what we said for cosine of theta. We said cosine is adjacent over hypotenuse. Well, the adjacent is the x value and the hypotenuse is the r value. These same things would happen no matter which quadrant you drew this triangle in. The x would be the adjacent, the y would be the opposite, and the hypotenuse would be the r. I just chose to draw it in the first quadrant. And then tangent of theta, remember we said tangent is opposite over adjacent, so tangent is y over x. So this is where these new definitions of trig functions come from. It's using SOHCAHTOA on a triangle that's within a circle. So a new way for us to define our trig functions if we are in a triangle within a circle, is that the sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, as we just talked about. Remember that cosecant, secant, and cotangent are reciprocals of the other three. So cosecant of theta is r over y, secant of theta is r over x, cotangent of theta is x over y. You absolutely must have these memorized. We are going to use this figure to help us think about the signs of the various trig functions in the quadrants. So if you are in quadrant 1, your x is positive and your y is positive. Now think about what r stands for. R stands for radius of a circle. Radius of a circle must be positive, so radius is always positive. If you are in quadrant 1 and you are using any combination of x, y's, and r's where everything is positive, then all your functions are going to be positive. So in quadrant 1, all functions are positive. Let's go over to quadrant 2. We know that r is positive. In quadrant 2, x is negative and y is positive. So let's think about what happens with the functions over here. If you're doing sine in quadrant 2, you're going to put positive y over positive r. You're going to get a positive answer. So if sine is positive, so is cosecant. Reciprocals are always the same sign as the original. Cosine is x, which is negative, over r, which is positive, so that's a negative answer. Tangent is positive y over negative x, so that's a negative answer also. So what happens in the second quadrant is that sine and cosecant are positive. Cosine, secant, tangent, and cotangent are all negative. If we go down to quadrant 3, x is negative and y is negative. In quadrant 3, r is always positive. So let's think about what happens with our functions here. For sine, y over r, negative over positive is negative. Cosine, x over r, negative over positive is negative. Tangent is y over x, negative over negative is positive. So what's going to be positive here is tangent and its reciprocal, cotangent. Those are the only ones that are positive. All the other functions will be negative. So sine, cosecant, cosine, and secant are all negative. In quadrant 4, x is positive, y is negative, r is always positive. So what happens over here? For sine, you're going to get negative over positive, so that's negative. Cosine, if you do x over r, you get positive over positive, so that's positive. Tangent y over x is going to be negative. So the two that are positive in quadrant 4 are cosine and secant. The other functions are all negative. So sine, cosecant, tangent, and cotangent are all negative in quadrant 4. For example 3, we are told that we are going to let the point square root of 11, negative 5, be on the terminal side of theta. Find the cosine of theta, cosecant of theta, and tangent of theta. Before we go into a graph, let's think about what this point is. We have a positive and a negative. If you have a positive x and a negative y, that puts you in the fourth quadrant. We're going to draw an axis, and then we have a terminal side down here. And what that means when it says let this be on the terminal side is that you have a point there that the square root of 11 and negative 5 are the coordinates of that point. So if you went from that point and drew a vertical, a perpendicular, so that now you have a right triangle, well then the x amount of that right triangle has to be the square root of 11, and the y amount has to be the negative 5. So we know two sides of a right triangle. How do we find the third side of a right triangle? We always use Pythagorean theorem. Square root of 11 squared, x squared, plus y squared, negative 5 squared, has to equal, we're not going to call it z in this case because that's a radius. We're going to call it r squared. The square root of 11 squared is 11. Negative 5 squared is 25. That has to equal r squared, so we get 36 equals r squared. So r is plus or minus 6. Think about what we said about r. R is a radius. Radius must be positive. So the hypotenuse of this triangle that we just came up with is 6. So we now know that x equals square root of 11, y equals negative 5, and r equals 6. So to do the functions we are asked to do, we want to do the cosine of this theta. We just said that cosine equals x over r in our new definitions. So if we put our x over our r, we get the square root of 11 over 6. Cosecant of theta is the reciprocal of sine. It's r over y. So we're going to have 6 over negative 5. You can rewrite that as negative 6 over 5, make the negative out front, but it's fine either way. Tangent of theta is y over x, so we're going to put negative 5 over square root of 11, and we're done. On example 4, we are told to find the values of the remaining trig functions if cosecant of theta equals negative 3 and theta is in quadrant 3. So we know that the cosecant of theta is negative 3. Let's think about how we defined cosecant. We said that cosecant equals r over y. And our r over y has to be 3. Think about 3. 3 can be written fractionally as 3 over 1. And we need this thing to be a negative, but r has to be positive. So that means that the y value has to be negative 1. So right now we know that r equals 3 and y equals negative 1. What we don't know is x. But if we are in quadrant 3, both x and y are negative. So we're going to do the Pythagorean theorem to find our x value that we don't know. So the version that we want to use is x squared plus y squared equals r squared. I know a lot of people learned a squared, b squared, and c squared. We're going to use this version. It's the exact same thing, we just use different letters. Remember, x is what we don't know, so we're going to leave that as x squared. Our y is -1 squared, and our r is 3 squared. So we have x squared plus 1 equals 9. X squared then has to be 8. So x has to be plus or minus the square root of 8, but that simplifies to be 2 square root of 2. So we now know our x value. We know that x is, and remember we're in quadrant 3, so it has to be negative 2 square root of 2. So going up here to do our trig functions, sine of theta has to be y over r. So it has to be -1 over 3. Cosine is x over r. So it's going to be -2 square root of 2 over 3. Tangent is y over x. So we're going to have -1 over -2 square root of 2, but that becomes +1 over 2 square root of 2. Secant is r over x, so we're going to have 3 over -2 square root of 2. And cotangent, since tangent was positive, cotangent will also be positive. We're going to put 2 square root of 2 over 1, which is just 2 square root of 2. In example 5, we are asked to give all 6 trig functions for the angle theta if cosine of theta equals radical 5 over 8 and the tangent of theta is less than 0. We already know cosine, so we're going to go ahead and put that in there. Square root of 5 over 8. Think about how cosine is defined. It is x over r. Since the entire fraction is positive, then we know that each of those items is positive. Therefore, x equals square root of 5, r equals 8. What we don't know is y. And we have to think about the sign of y also. Let's go back up here to our given information. We know that cosine is positive radical 5 over 8. Where is cosine positive? That's what we have to ask ourselves. Cosine is positive in quadrant 1 and quadrant 4. This second item of tangent theta less than 0. Now remember what that means when you say less than 0. We are being told that tangent is negative. What quadrants has tangent negative? That happens in quadrant 2 and quadrant 4. In order to determine where our triangle is, you want to see which quadrant they have in common. They have quadrant 4 in common. That tells us that our triangle that we are talking about has to be in quadrant 4. If we are in quadrant 4, then x is positive and y is negative. So that's our takeaway from this. That was the whole point of giving us this tangent less than 0, was to help us figure out that y must be negative. Coming back down to what we know so far, we know x and we know r, so we need to do the quadratic formula to find y. X square root of 5 squared plus y squared has to equal r, which is 8 squared. Square root of 5 squared is 5, plus y squared. 8 squared is 64. Subtract your 5, you get y squared equals 59. Y has to be plus or minus the square root of 59. Now we know our y value, so we can go up here and say that y has to be, remember we said negative, square root of 59. We need to find the remaining 5 trig functions, and we said that the sign is y over r. That will give us negative square root of 59 over 8. Tangent is y over x. In this case, that will give us negative square root of 59 over square root of 5. Alex does not require that you rationalize anything. You can leave that in that radical form. For cosecant, we're going to flip the sign, so we will get 8 over negative square root of 59. For secant, you're going to flip cosine, giving us 8 over square root of 5. And cotangent, we're going to flip tangent, so we're going to get square root of 5 over negative square root of 59.